Hello, this is Aiden Petruska, and this is Physics Lab number 2. What is the purpose of this lab? The purpose is to observe the effects that gravity and drag have on an object that is in free fall, using an observed model and two computational models, one with drag and one with only gravity. The fundamental principles used is Newton's second law with gravity and drag, and Newton's third law with gravitation between the ball and the earth. The main result of this lab is that the computational model that includes drag is much closer to the observed model than the computational model without drag. Okay, the principles used. Obviously gravity, as the gravity pulls the ball down. Drag, as the air pushes back up against the ball as it moves down, and velocity update and position update. Okay, this is the observational model that I did. The initial conditions were the mass of the beach ball and the starting position. I dropped my beach ball from just the top of my door, and then I used tracker to put the axes in, and then click the ball on the bottom of the ball each frame to record the position. In this scenario, the system was the beach ball, and the surroundings was the earth and the air. Okay, the computational models, code. This is the data that I used for all the initials, conditions, and the code. Delta T equals 0.76 or 767. Starting height was 0.0086. Mass was 0.0453. And then the B I found to give me the most accurate results was 0.028. And then this was gravity for the ball. Okay, my computational model with only gravity. So, using that gravity that I had on the last slide, I put that into the FNet, and I updated. After that, I used the velocity update formula and the position update formula to update both the velocity and the position of the ball for only gravity. But for the gravity and drag one, I used the drag formula, which was B times V squared, and I added that on to gravity and then did the same thing with the velocity update, position update. And this was the results of the lab. The computational model with purple, the purple line here, was a lot more accurate than the model of just no. The computational model with drag in purple was a lot more accurate than the computational model with only gravity. It predicted the final position better. Possible errors in the lab was the mass of the beach ball was calculated wrong, incorrectly marked position in tracker due to blurred motion of the beach ball, and camera error. What if, and what does this mean? What if the beach ball was thrown downward with initial velocity, the terminal velocity would still be the same because the force of drag is based off the object's velocity. This is why the beach ball capped out at around -4 meters per second. What does this mean? The computational model without drag has constant acceleration, shown by the orange line. Shown by the purple line is the model with drag. Acceleration starts to slow down when the object gets to around -3 meters per second squared and tops out around -4 meters per second squared, which shows terminal velocity, where F drag is approximately equal to F of gravity.